Today is the last session of this course. So in the last week, we actually discussed the PSTN, that is the public switch telephone network. So my basic intention was that before discussing the GSM, we should have some idea about PSTN, because at the end of the day, somehow the GSM or this mobile phone networks, they're going to connect to the PSTN. So that's why we discussed little about the PSTN. Then we discussed the basic concepts of the GSM network. So we discussed these things last time. So how these PSTN networks uh, expand. So initially, the idea was having a fully interconnected network, but it is not practical or it is not scalable. So then we had some centralized switches, and then different levels or different hierarchies of this centralized switch. Then we discussed this architecture where we have different uh, switches, and each and every small networks, like different small networks, were connected with this next level switches. So likewise, the communication will happen through these different levels of switches. And then we discuss how this data communication was uh, emerge, and how they use the same infrastructure, the available PSTN infrastructure, to do the data communication. Then we discussed that there were some issues or limitations in the basic network communication. Therefore, people have introduced these digital subscriber lines. Still, they use the same infrastructure, but they were able to increase the data rate, and they were able to do the voice communication and data communication parallelly at the same time. So I showed you some diagrams. So this is how they have done it. So they keep a separate uh, channel for the voice communication, and set of channels for the upstream, and a set of channels for the downstream. So with this method, they were able to do all the data communications and the voice communication parallel simultaneously. And we discussed that we need a special device which is called as splitter to do this. So all the voice and the data is sent through a same link, and at the receiver's end, we use a device called splitter to split the voice and the data. Then we use the same infrastructure, same telephone line, to do both the communication. Right, and we discussed the difference between packet switching and the circuit switching. Right, so in telephone communication, we need to have a circuit switching. So that's the initial architecture that we had, and packet switching was used for the data communication. Right, so we discussed those things, and we came to the cellular network. So we discussed the reason for use the term cellular. It is not because the size of the user equipment, right, or the mobile device. It is because we have these different geographical areas, yeah, each and every cell tower is responsible for. So we have geographical areas like this, as shown in this diagram, the hexagonal shape geographical area. So that is the cell. And so we have a network like that. So each and every cell has different frequency ranges. So with that, we reduce the overlapping of these frequencies. And that's how the cellular networks came, right? So we discuss from 1G to 4G, actually, the difference and how they have evolved. So basically, the people need uh, more uh, faster or communication links. So that's how these different generations came. And so there's a significant difference between the data speed in each and every generation, right? And the link capacity changes and the latency changes. And sometimes they introduce different services in each and every generation, like from first generation to the second generation, they have introduced the SMS. So likewise, when it comes to the 5G, 4G, the lot of IoT and high bandwidth data communication, right? So there were different services introduced when it comes to the different generations, right? And we discussed the 1G, 2G, then the GSM architecture, right? So base station controllers, right? So we discussed these things last time, and the 3G, and we discussed the 4G as well, right? So those are the things that we discussed last time. And today we are planning to discuss some security related things in these different generations. Right? So I'm not going to discuss the technical things in deep, right? So I will give you some preferences even in the slides. I have referred some of these things, some research papers and some blog posts, some documentations. So if you are interested, then you can refer those extra materials to get some more idea. But for this course, I'm not going to go in deep on different technical stuff, but we need to have some basic ideas of how these things work, and what are the security. Okay, so sorry for that. We have a power issue at UCSC. All right. Okay, so Yeah, let's start the discussion with 2G. I hope you can hear me. And so let's start our discussion from the 2G. So I will discuss some security issues in 1G later, but now let's start our discussion from 2G. So if you consider 1G, actually 1G is totally analog. So there are some security issues related to 1G, like phone. I mean, the cloning of this seems like the mobile phone. So likewise, we have some security issues in 1G. But when it comes to 2G, we are having a digital communication, right? So let's discuss how these things are working in the 2G. So actually, the SIM is one of the most important part in 2G. So where the SIM is introduced, a smart card, and this is the part where a lot of security stuffs come, right? So in the SIM card, you have some information saved. It is a smart card, so you can store some of the information there. So especially in the SIM card, there's a security key. A secret key is stored inside the SIM card, and the secret key is used by the network or this service provider to authenticate yourself or authenticate the subscriber. And so that's one important part in this 2G or in the second generation. So with the introduction of the SIM cards, so they have introduced the secret keys, right? So as you can clearly see it in this diagram, so this is how the communication is authenticated and the data encryption happens, right? So we discussed that in the first generation, we are having analog communication and there's no encryption in the first generation, right? But with the second generation, this subscriber authentication and the encryption was introduced, right? So you can see this in the diagram. So the GSM operator or the service provider is actually sending a random number or a challenge to the subscriber. Right, so this this random number is 128-bit random number, a challenge. So that is transmitted from the network operator to the subscriber. Now what the subscriber does is, subscriber's SIM card, so it has that key that I told you, this is the KI is the key. So you have that key in the SIM card, right? So there are different algorithms, so don't need to think about these algorithms that much. So A1 is such that algorithm, so it is authentication algorithm. So the mobile phone or this subscriber, inside the SIM card, you have this key, the KI, and you use that key and the random challenge or the challenge that is sent from the operator, and you generate a response, right? So we called it as a signed response. That is this SRES, right? So you get a random challenge from the operator, and inside the SIM card you have the key, and you use both this random number and the key as inputs to the authentication algorithm A1, and you generate a signed response. So that is this SRES, right? So after generating this SRES, your mobile phone will send it to the operator, right? So in the operator, again back, the operators have each and every keys for different subscribers. So that is actually saved in a different place, which we called as authentication center. I can't remember whether we had that in the diagram, the 2G diagram. Yes, you have this authentication center, right? If you check the 2G architecture, you have a component called AUC. So that is the authentication center. So this authentication centers and this HLR, so we have different registries we discussed last time. So they keep this information, the keys and all the thing. So they use that key and they calculate the stress. And after that, they will compare it. So whatever the stress sent from the subscriber and the stress generated by the operator, so they are going to compare it. And if it is same, then they are going to authenticate the subscriber, right? So that's how the GSM operator is going to authenticate the subscriber. So that's how you are authenticated. Your mobile phone or your SIM card or whatever you is authenticated by the GSM operator, right? So that is the authentication part. So after that, the GSM operator knows that you are connected with the real user, right? So that's the first part. So authentication part is that. So for that, we use that algorithm, A3 algorithm. And so these are kind of little bit old algorithms, right? But anyway, this still we are discussing about 2G. So they're using A3 algorithm to do this. So don't think about what happens inside the A3 algorithm. So we are not going to discuss deep about these things. But anyway, they use the A3 algorithm with the random number and the key to generate the response. And that response is going to be used to uh, authenticate the user, right? So that's the first part. So remember that these keys, the KI keys, so they are not going to transmit that KI keys. So in any option, the GSM operator or the mobile subscriber, they are not going to transmit this KI over the air, right? So they are going to be securely stored on the SIM card, right? So which means it is not easy for the uh, uh, the intruders or for the attackers to extract it, because if it is going to be transmitted over the air, then they can capture it and extract whatever the case. But the thing is, it is stored in the SIM card, so therefore it is not going to be uh, transmitted over there. Therefore, they cannot extract it, right? And you know that in SIM cards there's a PIN as well, right? It's a personal identification number, right? So those kind of things are used to protect whatever the things in the SIM, right? So there are some security measures in the SIM as well, right? So the SIM will be locked if you use some incorrect pins. So likewise, there are some security measures in the SIM card as well, right? So remember, so all this authentication part will be done by the AUC, right? So authentication center in uh, the operator, the GSM operator, right? Okay, now the next part is the encryption. So we discussed the data communication between the mobile phone and the uh, GSM operator, or the cell tower is going to be encrypted. And so that is the next part of 2G. So they are going to use this same information, right? The SRES. So they use the same calculated values, this SRES, to do this encryption as well, right? So So after this authentication process successfully completed, right, then the express value generated is actually passed to the next algorithm which they are going to use, that is A8. So they pass this SRES to the A8 algorithm again with the KI key, right? So with this, they are going to generate another key which is going to use for the encryption, that is KC, right? So only one variable is shared with the GSM operator and the mobile subscriber. So that is the random number or the random challenge that they send to do the authentication. So that random challenge is sent to the mobile subscriber. So they use it as an input for the A3 algorithm along with the key. Then with that, they generate this SRES or the response. So this response is going to be used for the authentication, right? After that, they use the same response as an input for the A8 algorithm and the key KI. With that, they generate the KC. So this KC is going to be used for the encryption, right? And again, for the encryption algorithm is A5 algorithm, right? So this algorithm is implemented in the hardware of the mobile phone, right? So this encrypted data will be then sent over the air to the operator, right? So the operator, again back in the operator, they have the stress and they know the KI relevant for this particular subscriber. So by using the stress and the KI, again they use the same A8 algorithm. So with that, they generate the KC key, and then by using the A5 algorithm, they decrypt whatever the message, right? So A8 algorithm is going to use to generate the ciphering key, and A5 algorithm is going to be used to do the encryption and the decryption process, right? So this is basically A5 is like a stream cipher, right? So this generated KC, whatever the key is, going to be used to encrypt the communication, right? So it is basically the voice communication that you are doing and the data that you are going to transfer between phone and the base station, BST, right? So with this, you can reduce the or you can prevent the eavesdroppers, right? So whoever the people try to listen to your communication, so this will reduce that. But anyway, there are different types of A5 algorithms. So if you search this, you will find that there are different versions of A5, right? So some of them they use 64-bit keys, right? And some are very weak versions are there, and there are some A5 algorithms which uh, do not perform encryption. So likewise, different versions of A5 algorithm is there. Right, so that's why I told you these things are a little bit complicated, and so complex processes are there. But anyway, we'll have some basic idea. So what actually happens in 2G, right? So the challenges or the problems with 1G was the communication is not encrypted. So if the attackers have some devices, then they can listen to the communication. So it is not encrypted. But when it comes to 2G, you have digital communication, and you are trying to authenticate the subscriber, which means your mobile phone is going to be authenticated with the GSM operator. And the next part is whatever the voice or data you are sending from your device to the cell tower is going to be encrypted. So with that, you can prevent that eavesdropping, right? So this is the basic idea of 2G, and that is how they try to provide some security for the communication. So it is better than the 1G, because in 1G there's nothing, right? So, but when it comes to 2G, yes, you provide some security, you provide some encryption, and you are authenticated. Your device is authenticated, right? And this is actually the image I took from RFC, and I have put the link as well. And so it shows how the things actually happen in the RFC. So there are some maybe some differences with how the things are implemented. But anyway, this is how the RFC shows the communication, the authentication and encryption. So go to the link and read if you are interested, right? So that is the basic idea of 2G, how the communications happen between the cell tower and the your mobile device. Okay, right. So we are back again. Yeah, in power. So I'm going to show you switch back to Wi-Fi. Right. Okay. Hope you can hear me. Right. So remember that in any case, they are not going to transmit these keys, right? So Ki and Kc, they are not going to transmit them. So at both the ends, this Ki and Kc are generated by using the random challenge that they initially shared, and the keys are the Ki is there, right? So Ki is there in the SIM and as well as in the authentication center, because we have this uh, VLRs and HLRs. So those keep this information, right? So the operator has the information. So by using that, they are going to generate this KC, and so they are not going to transmit them anyhow. So because of that, we can provide some security, right? Okay, then so let's see how the 3G works, right? And remember, in 2G, only the subscriber is authenticated, right? So actually, in the 3G, in 2G, one of the attack was that you can create a rogue base station, right? So because there is no way to check whether you are connected to a real cell tower, and so that's one problem they had in 2G. So to avoid that problem, in 3G, they have introduced this mutual authentication. So in this case now, we are going to authenticate both the subscriber as well as the operator, right? So in 2G, so don't mix these things. So remember clearly, in 2G, you are going to authenticate only the subscriber. So which means you, right? Or the mobile phone user, the SIM card on the device. So you are going to authenticate that, not the GSM operator, Mobitel, Dialog, or whatever the GSM operator. You are not going to authenticate the operator, right? But because of that, the attackers can represent as a service provider, right? So they can create some rogue access point, like rogue cell towers, right? So to avoid that, in 3G, they have introduced the mutual authentication. So authentication and key agreement, AKA. So we'll use that here and there after this, because 4G, 5G, all these things, they use enhanced AKA, right? So this is the place where they do the mutual authentication, which means both the subscriber and the operator are going to be authenticated, right? Now I have a nice diagram for that. Actually, I took it from a research paper. I have put a link of that research paper as well, right? So rather than drawing it by myself, I simply took it from that particular research paper. So you can go and see how these things actually work, right? Now, the first part is you have to authenticate. Now you have to authenticate both the subscriber as well as the operator, right? So again, the network operator, they are going to send that random RAND, like in the 2G, they are going to send the random, right? And other than the random, they are going to send another information, that is authentication token. So that authentication token is going to be used to verify the operator, right? So now you send two things, the random, which is the challenge, RAND, same as the 2G networks, and you send another thing, another information, that is the authentication token. Right, so don't think about how these things are actually the diagram shows how these things are going to be generated and the algorithms are going to be used. Right, so don't think about them. Just think that you're sending an authentication token. Right, now the subscriber has two things. One is the random and the authentication token. So they use the authentication token and do some calculations, and with that they verify the operator. Now your dialog or Mobitel or whatever the service provider is authenticated. Now your device knows that, okay, I am connected to a real service provider. So that's by using the authentication token, right? After that, your SIM card, it actually calculate this response like in the previous case, right? So that response is generated or calculated by using the secret key. And so secret keys, they are in the SIM card as well as with the uh, uh, the service provider. Right? So service provider means the authentication center. So HLR keep all this information, right? So that calculation happen in the operator as well as in the subscriber. So by using that key, they are going to generate the response and send back the response to the operator, right? So with that, now you are authenticated, right? So it is the same procedure that you have used in the 2G, but the extra part is that you are sending an authentication token. So by using the authentication token, you are going to authenticate the service provider or the operator, right? And there are some advanced mechanisms like this AK protocols, they use some sequence numbers. So likewise, it has some extra parts to check whether these authentication vectors are going to be used again and again, right? So they try to avoid this replay attack. So a lot of security stuff are there, right? So they have done a lot of things to reduce these different attacks. Uh, but for now, let's think that they are sending authentication token from the operator to the uh, subscriber, and by using that authentication token, they authenticate the subscriber. Sorry, authenticate the operator. And like they did in the 2G, they use the random value and the keys, and by using them, they calculate uh, the response. So the response will be sent back, and uh, they uh, authenticate the subscriber, right? And the thing here is they have changed some of these algorithms. Like in 2G, we have five-way. So the five-way is replaced with some other algorithms. Like you can see that in the diagram, it is represented in F letters, right? So F8, F9. So likewise, there are different block ciphers, right? The different ciphers, different algorithms are used. And yes, I have some information. So there are different algorithms are used for this, right? So in some references, you will see this as Kasumi, right? So algorithm Kasumi. So I don't know how the name came, but that's the name of the algorithm. So it is 120-bit key uh, algorithms, right? So uh, this is how they are going to improve the security, right? So because there were some problems with A5, so to avoid those problems, they have introduced some different algorithms. So F8 for the confidentiality and F9 for the integrity. So you can see how these algorithms are used. And in here you can see some how the keys are, the KI and KC are generated. So these are 128-bit keys, right? So likewise, some improvements are there, right? So they use the CK to do the encryption part, and integrity keys to protect the integrity. So that is another important thing, because now you are doing the integrity, checking the integrity as well. So which means in the middle of the communication, if the attacker tries to change something, then that will be also checked, right? So whether the message is changed or not. So in 2G, it is only encrypting the data, but now with the 3G, you are doing the integrity check as well, right? So with that, you are checking whether the messages are changed in the middle of the communication, right? So some improvements to the 2G when it comes to 3G, right? So if you are interested, just you can go to this research paper and get some more idea, right? And I have put uh, some link of the Wikipedia pages as well. It is about this F8 and F9 algorithms, right? So how they behave and how they work, right? And uh, there are some different key management mechanisms used in 3G, right? So there are some hierarchical key managements, right? So different approaches are there, right? So then we can go to the LTE or 4G, right? So again, in this case, they are using the AKA, but a little bit enhanced, right? So they have uh, improved the AKA algorithm, which is used in the 3G. And so still it has that same mutual authentication concept that is introduced in the 3G, right? And so still you have the SIM cards, so which store the secret key, right? And it is again saved in the operator, right? So so you use the same procedure, right? So the operator will send a random challenge, and with the authentication token, right? So you calculate the response and send back the response to the operator. So the method is same, right? Yes, I have a diagram, right? So the method is same. So you are sending that random value, and after that you generate that response. So you can see the response is generated, and with that you authenticate the subscriber, as well as by using the authentication token you uh, authenticate the operator, right? So the same method, but it has little bit improved, like the LTE, they use, if I can remember correctly, 128 block ciphers, right? So, and they have used AES, I think, for the encryption. So, the thing is, they improve the encryption algorithms, right? So they have used different types of algorithms to improve the security, right? So in the encryption part, they have used AES, I think, right, to do the encryption. So that's how they are going to improve the security, right? So again, I have put a link in the web, the uh, slides. So it has some comparison between 4G and 5G. So how both is going to work, right? So remember the story is same. So the operator will send a random challenge, and the subscriber is going to use algorithm and the key stored in the SIM card to create the response. And that response will be sent back to the operator, and they use that response to authenticate the subscriber. So that is the same method or procedure used in all these generations. But the difference is they use different types of algorithms. So when they are using a more secure algorithm, then the communication protocol of the generation become more secure. And from the 3G onwards, they are going to authenticate the operator as well, right? So that is the change or the improvement that they have done. So all the other things are related to the protocol. So based on whatever the encryption algorithm and whatever the method they use to check the integrity is going to change, right? So based on that, they have improved the security of each and every generation, right? Okay, so let's discuss some of the security issues or threats in different generations, right? So I have list two security threats in 1G. So the first one is cell phone cloning, right? So this is one of the major problem identified in the first generation. So as we have discussed, there was no built-in authentication mechanism in this first generation, right? So actually, there's no protection, zero protection in the 1G. Right? So anyone can do, if they have the relevant devices, then they can easily do the channel hijacking and this cloning, eavesdropping. So everything is possible, right? So you can see in the a diagram, right? So there's a cell tower, right? And the original mobile phone is there, the phone user, right? So the attacker can actually eavesdrop the communication because there's no encryption going on, right? So they can listen to the communication, and if they have these sophisticated devices, like the radio receiver in the diagram, you can see it is mentioned as radio receiver. And what they do is they extract some information like the ESN, that is electronic serial number, right? Serial number relevant for the communication. and some a mobile number and all this information. So they can sniff the communication and extract the information. And later on, by using some tools, they can burn those information into another mobile phone, and simply they can clone the cell phone, right? So that is one attack that they have in the first generation, right? So they can behave as a different person, right? So they can simply clone a cell phone, right? So after you did it, so it is very uh, difficult to differentiate this victim and the clone cell phone, right? So that's one problem they have in the first generation, right? So with that, you can do this hijack the communications, and easily you can eavesdrop on uh, calls because they are not encrypted. So the only thing is you need to have these devices which can tune into the frequencies of cell phones, and you can easily listen to the communication, right? So this is first generation. So that's why the second generation was introduced, and the encryption is introduced in the second generation, right? So these are very basic attacks at that time, right? So when it comes to the second generation, right? So as we discussed before, the one major problem in the second generation is, though you authenticate the subscriber, you are not authenticating the base station, right? So that's the main problem in the second generation, right? So you do all these challenges, and the response is sent back to the operator. So somehow the subscriber is authenticated, right? But still, the service provider or this base station is not authenticated. So the attackers can create some rogue base stations, right? So they can behave as real service providers. So, but the problem is those are simply fake, right? So that's one problem. So in that case, you can understand that the attackers have access to all the communication that you are doing through that rogue base station, right? So attack has access to everything because all the information are traveled to the rogue base station, right? So not only the voice traffic or the voice calls, even you can remember at that time 2G, you have GPRS and Edge, right? So those communication are also goes through the rogue BST, right? So therefore, all the information can be collected by the attacker or the man in the middle. So actually, these things can be done very easily if you have the tools, right? And even there are some open source softwares to do this, right? So you can create a rogue access point, right? So I think you can remember we did some practicals in wireless networks, right? So all the tools that you are using were available freely. So likewise for this also. So there are some tools which are available, right? So a person can easily create a rogue base station and allow the users to do the communication through that, right? So the only challenge with this is when we compare to wireless, the Wi-Fi attacks, they need to have some devices, right? So you can't create a rogue base station with your laptop, right? You need to have some antennas which emit and receive these GSM signals, right? So that is the only requirement that you need to have. So others are simply computer softwares, right? By using that softwares, you can uh, do the attack, right? Or create a rogue base station. So this is a common attack in the second generation. So that's why, as we discussed in the previously, in the 3G, they introduced the mechanism to authenticate the access point or the base station as well, right? So with that, they try to reduce this so-called problem, rogue base station, right? And the other thing is messages, message spamming, right? Now, as we discussed before, in each and every channel, they introduce, not channel, in each and every generation, they introduce new service, right? So from first generation to second generation, they have introduced SMS, right? So which means we are actually expanding the attacking surface for the attackers, because now you have a new service. So the attackers can use that particular new service to do some attack. So that is this message spamming, right? So you have a new option. So they use that new option to do attack, right? So the people have sent a different SMS, right? Spamming. So that will fill your inbox, right? And send some unwanted messages for marketing maybe, right? So misleading information. So likewise, the spamming also they are in the second generation. So remember that when you are providing new services, then again that will give another chance for the attackers to do some attacks, right? Right. The next thing is 3G, right? So as I mentioned in the slides, now, and I mentioned you before as well. So now they are providing different services, right? And now the mobile data part of the communication has improved. So you are providing higher data rates. And the other thing is, that's another change in this from when you come from 1G to, sorry, 2G to 3G, you are actually uh, changing the devices, right? So at this moment, when it comes to 3G, then the different devices are introduced. Example, in this time, the Android devices are introduced, and parallelly the iOS devices were introduced. But now the attackers, they have a different domain to do the attack. That is the mobile operating systems, right? And the other thing is, so if you can remember when you are using the 2G phones, so they doesn't have a much sophisticated operating system, or there were no such applications, right? But when you come to the 3G, and with the 3G, a new set of devices were introduced, like the Android phones and the Apple phones, and they have their own mobile operating systems, and there were developers who develop different applications to use with these devices. So in that case, we have expand the surface, or the threat surface, right? Now the attackers have a lot of areas to do the attacks, like the vulnerabilities in the mobile operating systems and the vulnerabilities in the mobile applications, right? And they can simply put some malicious code, right? And they can get unauthorized access, and they can get the sensitive personal information, or maybe at least the contact information, right? Or maybe some passwords, location, because now these devices, they have a lot of sensors, not like in the previous case, right? So now they have the GPS locations, right? And you have different applications, web browsers, so people try to use surf web using these mobile devices. So because of that, the attackers have a different level, can do different level of attacks now by using the vulnerabilities of these softwares, right? So, and the other thing is they can uh, uh, introduce, so they can install some malwares and spywares to the devices. So with that also, uh, they can do some attacks. So rather than targeting on different, I mean, difficult attacks like doing in hardware level or in signal level, now they have a different areas to do these attacks, right? So still these technologies, they are using the AKA, so as we have discussed before, so they are using this 128-bit keys to do all this encryption and integrity and all these things, right? But still, the problem is that the software vulnerabilities, right? So still the man-in-the-middle attacks were possible in this case, right, by using the tools and the mobile signal jammers, right? So jamming you can do, it is not that hard, right? So if you have the antennas, then you can bombard the signals, right? So you can do the jamming. It is easy, right? So very simple. You can jam the signals, right? So still those kind of attacks are there, right? And you know that now all these things are, especially in 4G, everything is IP based, right? So because of that, so a lot of attacks or threats are there, right? Okay, so this is 4G, right? So you can see that the threat space has expanded, so not like in the previous case, right? So you can see that malware, spywares, those kind of things are installed in your user device, right? And still the rogue uh, base stations are there, the man in the middle attacks can be happen, right? And you can see that DDoS attacks can be happen in the middle. And so likewise, the threats space has expand, right? So the attackers can do or the attacks in a different domains or in multiple domains, right? And especially these virus attacks, the malware attacks, because now you are having a very complex, complicated operating systems in the mobile phones, and the users are installing some applications, sometimes third-party applications in the device, and even the users, they use different types of applications, maybe games, utility games, utilities, games, right? And banking apps. So all these things are in the mobile phone now. So the attackers have different ways of doing attacks, not only by using signal and uh, introducing some rogue access points, but they have a different ways to do the attacks, right? And all these things are IP networks now, right? So they can do uh, denial of service attacks, right? DOS attacks, right? So a lot of areas to do the attacks when it comes to 3G and 4G, right? Okay, then finally we came to 5G. Right, so I'm not going to discuss the technical stuff about 5G, and I think we have a separate session on special topics about 5G. And so we have very nice session done by a person specialized in 5G, about the 5G technologies and how the antennas and all those things work. So we are not going to discuss technical stuff that much, right, about the hardware and how those things work. But we'll go through some basic idea about the 5G technology, right? So the speed, yes, definitely it has increased, right? 20G theoretical value, right? So latency is very low, right? And another important thing is 5G is this IoT devices, right? And AR, VR devices, right? So, and different technologies like new radio, right? Service-based architecture, then network function virtualization, software-defined networks. And so all these things are introduced with the 5G, right? So the other question is why we need 5G. So these are the three things that I have found. So these are the three things that most of the articles and things mention. That is EMMB. So EMBB, that is enhanced mobile broadband. So which means the higher speeds, right? So around 20 gigabits per second. So people need more speed because now they have different applications like especially this video streaming, and now we are having this AR, VR devices, and so they consume a lot of data, right? So because of that, the subscribers or people need higher speeds. So that is one thing that we need 5G EMBB, right? Enhanced mobile broadband. And the other thing is massive machine type communication. Reason is, as I told you before, now there are a lot of IoT devices, right? So, and these devices, they need to be communicated with each other. So, therefore, again, 5G is required for that. So, there are a lot of millions and billions of IoT devices, right? So, they need to be communicated. So that is another requirement. But the 5G is important. Why the 5G is essential, right? And the third one is the URLCC, that is ultra reliable low latency communication. So that is especially for the mission critical applications, right? So as you know, these days there are a lot of discussions about these autonomous vehicles, right? Even I think the morning I also no yesterday I saw an article about some autonomous vehicles, right? The Tesla, the autopilot, and they are having a taxi, right? So robo taxi, I think. So there are some discussions about these things, and even in some countries they are having these things testing, right? In US also. So some government authorities they are publishing some articles about the problems with these things. So anyway, uh, they need to be communicated, right? So you can't have wired connections, so you can't find Wi-Fi always for these autonomous vehicles, right? So they need to be connected through the network. So therefore, they need higher speeds, bandwidth. So 5G is needed for them, right? And I think this another example is this remote surgery kind of things. And I have seen that some surgeons are doing surgeries from different countries nowadays, right? So in that case, the communication has to be very fast, right? So then some industrial automations, right? So for all these things, this low latency communication is very important, right? So that's why another part where the 5G is important, right? So still it has some security issues, right? So and for 5G also they are using the AKA concept, but they have enhanced it for the 5G communication, right? And they have introduced some other uh, security mechanisms, right? So 5G is the future, and 5G is the requirement for the current industry and current uh, needs of the people, right? So still you can see the threat landscape has expanded, right? So there are a lot of chances, opportunities for the attackers to do these attacks, right? And still, some of those things are based on the software, not in the infrastructure, right? So still, as you can see in the diagram, we are expanding. So from 1G to 5G, you can see we are using the same diagram, but it has expanded because when you expand in the services, so that means you are building some opportunities for the attackers to do the attacks, right? So you can see now the devices are increased. So previously you have only smartphones, now you have IoT, now you have autonomous vehicles and all the things, right? So that increase the uh, space where the attackers can do the attacks, right? So yes, I have listed some of these uh, threats, right? Uh, so uh, uh, so when you consider in this the nature of the 5G security threats, still we can see that uh, there is no boundary for these things, right? So it is expanding from this mobile phones to you can see in the diagram as well. So from the mobile phones to uh, the home automation parts to different maybe sensors, then the industries, right? So different enterprise networks. So there's large scale for the attackers to do attacks, right? So actually this is a serious problem for these security people to, I mean, find a way to uh, defend these systems, right? So yeah, I have listed the nature of these threats. So they're basically sophisticated, right? So complex, right? And they have to use some uh, uh, different levels of uh, uh, attacks uh, to attack these kind of systems. So basically what I'm saying is these attacks are not that easy. So they have to be very sophisticated attacks, right? So the attackers, they might have to use different toolkits or different uh, uh, application softwares to do this single attack, right? So attacks will be sophisticated, right? And the thing is, they have to do these attacks in multiple layers or different layers, right? And because of that, it might be difficult for or it will be difficult to detect these attacks, right? So that this is the nature of these 5G networks, right? So it will be hard to uh, detect these things, right? And uh, the other thing is these attacks. So there has to be evolve, right? Because once they fail, right? So they have to improve and evolve based on each and every failed attempts. So because of these factors, it is difficult for the security personnel or security persons to find mechanisms to reduce these attacks, right? So still these are new fields, right? So new areas. So still uh, it will be difficult for even for the attackers and as well as for the security practitioners to uh, find mechanisms to defend these things, right? And this advanced persistent threats. So this uh, these attacks will be, I mean, hard to reduce these attacks, and uh, they might target some critical infrastructure, right? So these large service providers uh, uh, may, I mean, with this, when they do these attacks for this different infrastructure, then these service providers may face some huge problems. So the what I'm trying to say is these attacks, since this landscape is huge, right? So it will be the first thing is it will be difficult to do the attacks because the attackers might need to use different levels of attacks, and they have to use different types of tools to do the attacks. And because of that, the security personnel also will face some problems to detect these attacks. And the other thing is it will be persistent because when they are going to fail by doing the attack, then they will learn it, right? So they will learn from these failed attacks, failed attempts, and they will continuously evolve and improve, right? So the thing is, the security practitioners, so they have to build this defense for the systems, and while they are doing that, the attackers, they will find new paths or new avenues to do the attack, right? Because still the reason is the threat landscape is huge. It's very vast, right? So there are software, there are hardware, and there are communication mediums. So lot of loopholes will be there. So that's what I'm trying to say, right? So because of that, there can be different types of attacks, right? And still the security practitioners, so they need to think how to protect these things, right? And they also have to continuously improve it, right? So that's what I'm trying to say. So security model, so how it has to do, right? So there has to be a proper surveillance mechanism, right? So they have to gain all this information, maybe telemetry data, right? So through kind of uh, a proper surveillance system, right? They have to monitor these things, right? And they have to have a proper security plan or security mechanism, right? and there has to be some defined processes and tools to identify these attacks or detect these attacks and block these attacks, right? And not only that, you have to evolve the system, right? So the system has to improve, right? So then the defense system. So not only that, so once you identify the attack, can you block it? Then you have to have some defense mechanism to keep that protection continuous, right? So this should be the 5G security model, right? So yes, I have listed some of these threats that you have. So most of these things are not hardware related, like we discussed in the 1G, 2G, 3G, right? So the ransomware. So that is one threat that you have in this situation, because you are now the attackers, they have a large space to do the attacks. So they might target on different areas like that. So ransomware. So they will encrypt everything, right? And demand some ransom money, right? Then the malwares, some advanced malwares, right? To extract some data from your devices, especially IoT devices. Now, they can create IoT botnets, right? So because these millions and billions of IoT devices are going to be connected to the network by using 5G, right? So easily, if attacker can pump some malicious code to these things, they can create a IoT botnet, right? So uh, this considered as a higher level of threat, right? Then critical infrastructure threat, right? So they might damage some critical infrastructure, right? Then zero-day attacks, right? So undiscovered vulnerabilities will be there in the system. Still, it is new, right? So the attackers, they can combine different types of attacks, as I told you before, right? Maybe they can combine different malwares or different botnets and do some zero-day attacks, right? That is, can consider that as a extreme security threat, right? So there will be some cyber activism like hacking, right? Then cyber crimes. So there'll be some criminal activities, right? So steal some information from the devices, then cyber espionage, right? So the people will get some illegal access to the network, so maybe computers, and again they can get some extract secret information, right? Cyber terrorism, right? So cyber attacks, right? Especially for the governments, maybe create some public panic kind of things, right? Cyber terrorism, cyber warfare, right? So a lot of things are there, right, in 5G. So still, mm, there are uh, there can be situations based on the 5G networks, right? So when it comes to the security, so I have mentioned the use authentication part. So they have enhanced it and it has 5G AKA. So if you're interested, just read about the 5G AKA. And so I want to give you some basic idea about how these networks evolved and how the security landscape increased. So with this, with these diagrams, you can basically understand that it is actually not the hardware part. So when the technology improved, or when the things get improved, it is coming towards the software as well, right? So it is not like in the 2Gs or 2G, this the rogue access point was one of the major problem. But when you come to 3G and 4G, in 5G, you can see that the threat landscape expands, right? So the types of attacks that can be happen has increased, right? So yeah, just think about these things and just read about the things, right? And uh, try to stay updated about the upcoming the technologies, the 5G and beyond, right? So with all these things, you can understand that it is we actually expand in the threat surface. So there are a lot of things that the attackers can think of, and they can exploit on these networks, right? And which means the security experts or security personnel, they have to think about all these avenues, and they have to be in alert about these things. Okay, so yeah, I think that's all about it. So we discuss a lot of things in this wireless and mobile network area. So we start from actually Android, the operating system. Now you can map why we start from there, because finally it comes to the operating system, right? So we discuss different levels of security, like the operating system level security, and then we discuss about little about the Android app level security, and then we came to wireless networks, that is from the hardware, how these things can happen, and we discuss the wireless communication level security, and finally we came to the GSM networks and how the security stuff is going on there, right? So I think that we have covered a vast area in this domain, the wireless networks. So the rest is that you can dig deep in different areas based on your interest and based on the requirements. So we have shown you some avenues, so showed you some paths. So based on the requirement, you can dig deep into different areas, right? So with that, I'm going to conclude the session. So we have complete the course, right? And uh, the exam paper will be will have 4 questions, right? So it's normal that how the paper is created, that you know that it has 4 questions. So it will be equally distributed among the things that we have discussed. And so you can refer the past papers, right? So you have 2 cybersecurity past papers, and there are MIS past papers as well, but there may be some differences, right? So because the content is little bit different in the MIS and MC, right? So you can refer the papers as well. So some questions are very similar, so therefore you can practice with MIS papers as well. But some parts might not be uh, same. There may be some different sections, right? Uh, okay, so with that, we can end the today's session. Right, so I hope I have uploaded the lecture notes to the LMS, right? And I will upload the rest of the lecture notes as well. And please complete the assignments before the deadline. So last week also I have published another assignment because I thought that we need to do some assignment on the wireless attack section as well. So therefore I have put a very simple assignment. So from what you have done on the practical day. So please complete that as well. Okay then.
So, small
Yes.
clarification.
Yes.
Uh, uh, is there any questions from the resource persons lectures that we had uh, the thousand zero five 1005
Thousand.
course?
Uh, you're asking about special topics, right?
Yes.
Yes. The questions will be from the resource persons. Yes. So
Okay.
the question paper might have MCQs as well as structured questions.
Okay.
Right. So based
Okay.
on yes,
Uh, Based on the lectures that they conducted, no, sir?
yes.
Okay,
So
sir.
there
Sir,
will be some structured questions and MCQ questions, both.
okay, sir. Sir, we have uh, that that regarding that assignment, we
Yes,
just use one thread on mobile applications. Is that okay? Only one
you
thread.
mean the first assignment, take-home
Yes,
assignment,
sir.
that secure application.
Yes, sir.
Yes, one thread is enough. So you have to mention the security problem that you are going to address and the method that you are going to mitigate that issue.
Okay, sir. Okay. Thank you very much, sir.
Right?
Okay, thank you, sir.
Okay, then. So this is the last time that we are meeting because I'm not conducting any lectures for you in the third and fourth semesters, but we'll meet on the independent studies. So most probably I will be the coordinator for the independent studies. Uh, okay then. So until then, uh, uh, yes, enjoy the degree program. Right? Okay. Thank you very much. Right.
Thank you, sir.
Thank you, sir.
Thank you, sir.
And if you have any feedbacks, I'm open for that. Right? So if you like to give any feedback, so feel free to give them. Okay then, thanks.